In this video, I'll present some important points for discussion when cleaning messy data. Well, when dealing with tabular data, here are some common types of messy data you may encounter. Quite often we see column headers are values instead of variable names, or the column headers are missing entirely. We see this quite often in CSV files, so you may have to assign column names before you even start processing what data you have. There may be more than one variable stored in a single column. Quite often it's delimited, or you might have one value, a space, and another value, or you could have they could be comma separated within a single column. So before you start doing any sort of analysis on it, especially any type of numeric computations, you need to separate that single column or split it into two columns. Some variables show up in rows and columns. You get inconsistent variable units across a table, usually in a single column. If you have a numeric type everywhere, then you errantly come across a string or a missing value. You'll have to know how to deal with that type of messy data. And then single observational units stored in multiple tables. So you could have the same column of information repeated across multiple tables, and you have other records across those tables, so you may have to join and merge tables and drop the duplicate columns from those tables. Now, what is a tidy data set? Well, everything is in a single table and it's consistent, so that's quite tidy. When there's nothing to readjust or separate, all the values are each in their own column, the columns have headers, and the values in each column are of a single type. Notice also in this table, you can transpose it on the first column and first row and still get a tidy data set. So that's kind of a neat little property of this particular table. Now, an untidy data set. Now, in this first example, we're going to talk about tangled variables. So this is not the worst case scenario. This tries to represent the data in a long format, so we have keys and values, but there are only two key values. So we could cut the row count in half if we just put population and cases as column headings in the data. So instead of key, if we put population here as the header and cases here, and then put the values in accordingly, we could have the number of rows in the table. Now we also have combined variable values, so we have columns that are encoding more than a single value. So here we have country, year, and value. So instead of having this as case and population, or cases and population, we have them encoded here with a slash as a delimiter. So what we'd like to do is add another column to the table, split the values on the slash, take the second value out, move it into the new column, and rename the column headers, the columns accordingly. So if we have something like this, it's not easy to compute means or any type of average or min-max value because we have too much information here, and it makes it harder to query the information that we need. Now here, values are in separate tables. We need a join here to use cases and populations together. Aggregating this information into a single table with cases and population as column headings would be preferable for any kind of analysis we'd like to do here. It would certainly speed things up and remove the duplicate country information between the two tables. So these examples were examples of messy structure in tabular data. The values themselves were generally consistent, which is not the worst case scenario. Being able to realign or aggregate information without worrying about the contents of the cells themselves is an easier scenario to deal with. But it's best to do this sort of readjustment early on, before getting into data analysis. Having the right tabular structure will typically give you a performance boost and often decrease the storage size you have to deal with. And that concludes this presentation on the need to clean messy data.